Welcome, traveler. I'm glad you could make it to our tour of the solar system. Today, we'll take you through an abbreviated 4.6 billion years of history, stretching millions of kilometers across space, from the blazing sun to the outer cosmic frontier. Strap in, lay back, and get ready to explore as our journey is about to begin. Our first stop is the heart of our solar system, the Sun. This glowing ball of plasma is our stellar anchor. It holds the solar system together with its immense gravity. In fact, the Sun contains 99.8% of all the mass in our solar system, which is equal to just about 1.3 million Earths. The surface of the Sun seethes at about 5,500 degrees Celsius. But that's nothing next to the core at 15 million degrees Celsius, where the Sun forges the energy that bathes our planets in light. The Sun's energy powers all the life on Earth, yet this star is an uninhabitable inferno itself. It's almost poetic. Without the Sun's steady shine and gravity, our solar system tour wouldn't exist. 8 planets and a host of smaller worlds endlessly orbit this central star, from tiny Mercury darting nearby to distant Neptune on the dark fringe. As we set on out to explore the solar system further, keep in mind that everything you'll see today owes its existence to the Sun's light and gravitational embrace. Our first planetary stop is Mercury, the airless planet. This little gray world is only slightly larger than our moon, and it's a land of extremes. With virtually no atmosphere to speak of, Mercury endures brutal temperature swings. The sun-facing side bakes at about 430 degrees Celsius or 800 degrees Fahrenheit for my fellow Americans. Then the heat radiates into space, and night plunges into negative 180 degrees Celsius or negative 290 degrees Fahrenheit. Mood swings almost as bad as your bipolar X. The landscape is cratered and barren, reminiscent of the moon, hammered by eons of meteoroid impacts. Mercury is also a speed demon. It races around the sun in just 88 Earth days, the fastest of all the planets. Mercury moves so swiftly that in ancient times it was named after the fleet-footed Roman messenger god Mercurius, or of course Mercury in modern English. Strangely, because Mercury spins slowly as it orbits, a single day-night cycle on Mercury lasts 176 Earth days, twice as long as its orbit. Meaning, if you stood on Mercury's surface, the sun would take half an Earth year to glide from one sunrise to the next. Although Mercury is the closest planet to the sun, it isn't actually the hottest planet. That title belongs to Venus, which is our next stop, thanks to a runaway greenhouse atmosphere. Still, Mercury's sunward side is incredibly inhospitable, and its night side is frigid. If you ever choose to visit, you'd experience one of the most extreme environments in the entire solar system. You'd freeze in the shade and fry in the sun. It's a world of light and dark, speedy orbits, and silent cratered plains where the sun looms 3 times larger in the sky than what we would see from Earth. In reality, Venus is more like Earth's mean, ugly stepsister that you kind of try to distance yourself from. Picture a world that's almost the same diameter as Earth, yet shrouded in thick, yellowish cloud layers that hide a hellscape below. Venus is the hottest planet in the solar system, even hotter than Mercury, despite being even farther away from the sun. Its dense carbon dioxide atmosphere acts like a thermal blanket, creating a runaway greenhouse effect that pushes surface temperatures to around 475 degrees Celsius, about 900 degrees Fahrenheit, hot enough to melt lead. And the air pressure at the surface is a crushing 90 times that of Earth's, equivalent to being about 900 meters or 3,000 feet underwater. Sure, I'm glad we aren't touring in a submarine. This scene gets even more dramatic. Clouds of corrosive sulfuric acid swirl in Venus's skies, and the terrain below features volcanoes and crumpled mountains warped by the intense heat. If you could stand on Venus, with an extremely robust spacesuit of course, you'd see a dim orange glow through the endless clouds. You might even spot lightning illuminating the dense gloom. Similarly to Mercury, a day on Venus is longer than a year. Venus spins so slowly and in the opposite direction of most planets that it takes about 243 Earth days to rotate once, whereas it orbits the sun in about 225 days. In other words, the sun would rise in the west and set in the east on Venus, and you'd wait the better part of an Earth year between sunrises. Not that you'd want to stay that long, as the combination of heat, pressure, and toxic air make Venus utterly inhospitable to life as we know it. Still, Venus is fascinating. It's a vivid example of a planetary fate gone awry, illustrating the power of an atmosphere gone out of control. It's as if our sister planet shows us what happens when the greenhouse effect runs to extremes. In stark contrast to our next familiar destination, Venus has no moons and no magnetic field to shield it. It's a beautifully bright object in our sky, often called the morning star or the evening star. But up close, it's a vision of a planetary underworld, intense heat, crushing atmospheric pressure, and a surface sculpted by volcanoes and acid rain. Now we arrive at Earth, our home and currently the only known oasis of life in the solar system. Earth is also the only known place in the solar system with access to the holiday classic, the Polar Express. From space, Earth shines as a pale blue dot with vast oceans covering over 70% of the surface, swirls of white cloud, and lush green rainforests. After the barren hostility of Mercury and Venus, Earth might just feel like stepping into a paradise. And indeed, it sits in the sun's habitable zone, just the right distance to have liquid water on its surface. Earth is the Goldilocks of the solar system, with temperatures that are just right. And we have a breathable atmosphere here that is rich in nitrogen and oxygen. So why is Earth so special? It has a robust magnetic field and an ozone layer that protect the surface from harsh solar radiation and abundant liquid water that helps to regulate the climate and nurture life. Our journey may be through the solar system, but for a moment, consider the marvel that's under your feet. Life in countless forms thrive here, from deep ocean microbes to towering redwood trees to the dashing views of video. The unique conditions that Earth provide make their existence possible. We also have a relatively large moon for a planet our size, a moon that stabilizes Earth's tilt and seasons. As we travel outward, it's worth reflecting that if we were voyagers from another world, this would be the crown jewel of the solar system. The only world blanketed in blue oceans, white clouds, the vibrant greens of life, and Blu-ray DVDs of holiday classic, Polar Express. Earth is the standard by which we compare all other planets, and so far none have matched its gentle, life-sustaining environment. It's our cosmic home, and in the vast dark of space, it's both stunning and fragile. If you were far enough away, Earth would appear as just a tiny blue speck point of light, a reminder of how small our planet is in the grand scale of the cosmos. With that last, appreciative glance at Earth, we continue onward, leaving the comfort of home for the frozen deserts of the red planet. Beyond Earth lies Mars, the red planet, a world that has captured human imagination like no other. As we approach, Mars greets us with its rusty red hue, colored by iron oxide, the rust, in its soil. This desert planet is smaller than Earth, about half the diameter, and has a thin atmosphere mostly made of carbon dioxide. Daytime on Mars can be mild, maybe a comfortable 20 degrees Celsius or 68 degrees Fahrenheit on a nice summer day near the equator. But don't let that fool you. Without much atmosphere to hold heat, nights plunge far below freezing. Mars is essentially a cold desert with the occasional global dust storm. Yet in many ways, Mars is Earth-like compared to the other planets. A day on Mars is just 24.6 hours, only slightly longer than Earth's. And Mars has polar ice caps of water and carbon dioxide ice that grow and recede with the seasons. However, the terrain here is dramatic. Here you'll find Olympus Mons, a volcano about 3 times taller than Mount Everest, which is the tallest planetary mountain in the solar system. It's 21 kilometers or 13 miles high, so large at the base that standing on its slope feels like a gentle incline stretching to the horizon. Mars also boasts the grandest canyon to end all Grand Canyons, Valles Marineris, a colossal canyon system that runs over 4,000 kilometers or 2,500 miles long, and in places plunges 7 kilometers deep. If it laid across Earth, it would span the entire width of the whole United States. These features hint at a geologically active past, volcanoes, tectonic forces, perhaps even plate tectonics early in Mars's history. But perhaps the most enticing thing about Mars is its story of water. Today, Mars looks dry and barren, but evidence suggests that liquid water once flowed on its surface in ancient times. Dry riverbeds, mineral deposits, and lake basins tell us that billions of years ago, Mars had rivers, lakes, and maybe even a vast ocean. It's as if we're looking into the sky at a post-apocalyptic Earth, a world that lost its habitability. What happened? Possibility that Mars was once wetter and maybe even home to life is a big reason that we have sent so many rovers and landers there. Currently, NASA rovers like Curiosity and Perseverance are roaming Mars right now, looking for clues of past life and collecting samples. As we leave Mars, we venture through the scattered debris of the asteroid belt. Contrary to what science fiction shows, the asteroid belt isn't densely packed with rocks banging into each other. It's mostly empty space filled with millions of rocks that are very spread out. We cruise past the dwarf planet Ceres, which is the largest object in the belt, and countless asteroids that silently orbit the Sun. Having safely navigated this vast expanse of rocks and ice, we arrive at the realm of the giants. Behold Jupiter, the king of the planets. As we approach, Jupiter looks enormous. Jupiter is so big that over 1,000 Earths could fit inside it. There's no solid surface here. If you tried to land, you'd descend into increasingly dense and hot layers of atmosphere until your spacecraft was crushed by pressure. Visually, Jupiter is stunning. Creamy white and orange-brown cloud bands wrap around the planet, driven by swift jet streams. These clouds are ammonia and water ices swirling in Jupiter's dynamic atmosphere. And then there's the Great Red Spot, the most famous feature, a gigantic storm 1.3 times as wide as Earth, raging in Jupiter's southern hemisphere. This oval reddish storm has been observed for over 300 years, centuries-long hurricane with winds of upwards of 400 kilometers per hour. Jupiter's entire atmosphere is a riot of circular storms and turbulent bands. Wind speeds can reach hundreds of miles per hour, easily dwarfing Earth's strongest hurricanes. It's a churning, seething cauldron of weather. Yet for all its ferocity, Jupiter has an almost regal beauty. Symmetrical bands, the iconic red spot, and fast rotation. A single Jupiter day is about 10 hours. And that makes those cloud bands visibly stretch around the globe. Perhaps one of Jupiter's most important roles is that of a gravitational guardian. Its immense gravity often slings comets and asteroids, potentially shielding the inner planets, like Earth, from some cosmic impacts. As our spacecraft flies by the cloud tops of Jupiter, we set our sights further out to the planet that perhaps win the prize for visual splendor. Saturn appears like a celestial artwork, immediately recognizable by its magnificent rings. It's the sixth planet from the Sun, a giant made mostly of hydrogen and helium like Jupiter, but it's a little bit smaller, only about 9 times Earth's diameter. The first thing everyone notices is going to be Saturn's splendid rings that are broad and bright, composed of countless chunks of ice and rock ranging from pebble to boulder-sized, all orbiting in a flat disk. They glint in the sunlight and give Saturn her majesty. Through a small telescope, those rings astonish. And up close, as seen by the Cassini spacecraft, they are intricate and structured into many ringlets with gaps like the prominent Cassini division. Strangely enough, Saturn is the only planet in the solar system that is less dense than water. If you could find a bathtub big enough, Saturn could be the universe's best-known bath toy. Saturn's rings often steal the show, but we can't forget Saturn's moons, which form an incredible entourage. As of now, Saturn has more moons than any other planet. Astronomers have confirmed 274 moons orbiting Saturn. Most are tiny moonlets in the rings, but dozens are sizable. The moons present a greatest hits collection of odd worlds, and the standout is Titan, Saturn's largest moon, which is bigger than Mercury. Titan is shrouded in a thick orange haze, the only moon in the solar system with a dense atmosphere, mostly nitrogen, like Earth's. Below those clouds, Titan's surface is remarkably Earth-like in some ways. Titan intrigues many scientists because its chemistry might be similar to early Earth's, and who knows, maybe some exotic life could exist in those methane lakes or subsurface. As we pass Saturn, we are treated to an unforgettable view. It's a reminder of the cosmic beauty that often borders on the surreal. Uranus. Uranus is so fat. No, I'm just joking. Often the butt of jokes for its name, Uranus is a planet that deserves attention for being truly unique. It's the seventh planet from the Sun and the first planet discovered in modern times, 1781 by William Herschel. Uranus is an ice giant like Neptune, with a bluish-green color due to methane gas in its upper atmosphere absorbing red light and reflecting the blue-green hue that we see. About 4 times Earth's diameter, Uranus is big. But it's much smaller than Jupiter or Saturn. What really sets Uranus apart is that it rotates on its side. Most planets spin with their poles roughly upright relative to their orbits, but Uranus's axis is tilted by 98 degrees. It's practically rolling around the Sun like a ball. The leading theory is that long ago, Uranus was struck by a planet-sized object that literally knocked it over. This cataclysmic event could also explain why its moons and rings are in the equatorial plane tilted with it. This means that Uranus's poles sometimes point almost directly at the Sun. Each hemisphere gets 42 years of continuous sunlight, followed by 42 years of darkness, since a Uranus year is 84 Earth's years. These extreme seasons make Uranus's climate and weather very intriguing despite the weak sunlight it gets. Uranus manages to have weather and seasons, perhaps due to internal heat or complex atmospheric circulation that we don't fully understand. As we sail past this sideways world, we press on to our final planetary stop at the fringes of the Sun's domain. Far out at roughly 4.5 billion kilometers from the Sun, just 30 times farther than Earth, we meet Neptune, the 8th and outermost official planet. Neptune is a twin to Uranus in many ways despite the less funny name. It has a similar size, similar composition as an ice giant with a serene blue color as well. But Neptune has its own personality. Where Uranus was subdued, Neptune is more visibly active. In fact, Neptune holds the record for the fastest winds in the solar system. Despite the Sun's feeble warmth out here, sunlight at Neptune is about 900 times dimmer than on Earth. Neptune's atmosphere generates supersonic winds that can roar at 1,500 to 21 kilometers per hour. It's an energetic weather system that puzzles scientists. How does Neptune's weather machine run so efficiently with so little solar energy? It seems Neptune might be radiating internal heat or has atmospheric dynamics that we still don't fully grasp. Neptune takes 165 Earth years to orbit the Sun, so seasons last over 40 years each. And we've only observed less than 1 Neptunian year since its discovery in 1846. Still, telescopes have observed that Neptune's brightness changes with seasons, hinting at dynamic climate variations. Neptune's deep blue color, more vivid than Uranus's teal, comes primarily from methane, but there might be some unknown components contributing to the rich hue. It's truly a beautiful planet, often described as a bright blue marble in space. As we bid farewell to Neptune, imagine the scene. The Sun is just a tiny, faraway light now, more like a distant flashlight than the blazing sun we know. The vast darkness out here is punctuated by that small sun and the distant stars beyond. We have effectively reached the edge of the planetary solar system. Leaving Neptune's orbit, we enter the icy expanse of the Kuiper Belt, home to Pluto and countless other frozen relics of the early solar system. Once our 9th planet, Pluto revealed its surprising complexity to new horizons in 2015. A world with mountains of water, ice, a heart-shaped plain, and even hints of a hidden ocean, reminding us that the frontier is full of unexpected wonders. As our journey through the solar system concludes, we have traveled roughly 4.6 billion years of history and billions of kilometers across space. Each world we visited has its own story, its own marvels and mysteries, and yet for all their differences, they are part of one connected family bound by gravity in the light of our Sun. The next time you look up at the night sky and see a bright dot, be it Mars with its reddish tint or Jupiter shining steady, you might recall what we discovered on our tour. Those aren't just points of light. They're dynamic worlds with volcanoes, storms, rings, and potentially life. In the end, this voyage through space isn't just about other worlds. It's also a journey of understanding ourselves and our place in the universe. Thank you for traveling along on this immersive tour of our cosmic neighborhood. Keep looking up, stay curious, and until our next stellar quest, safe travels.